A multimeter is one of the most basic and most important pieces of equipment in any repair shop. And this is what we use for pretty much any repair. You're gonna need a multimeter. Most multimeters are pretty much the same. Some have higher ranges, lower ranges, higher accuracy, lower accuracy. It's not that important. You really don't need to spend a lot of money on the multimeter. However, the heart of every multimeter and the most important part of every multimeter are the probes. There's a lot more to probes than you might initially think. Not only the selection of the probes, which probes to get, but also how to take care of the probes so they serve you a long time and they work consistently throughout the lifetime. So today we're going to take a look at few multimeter probes that I purchased, and we're going to pick the best one, and that's going to be my recommendation. They are all very affordable. There's not much to probes as far as the price goes. They're usually pretty cheap, although you can find some really expensive ones, but they're not going to perform super better or a lot better than the cheap ones. And as long as you take care of them properly, they should serve you for a long time. Hello friends, welcome back to the bench. Thank you very much for joining me. So recently I discovered that my probes that I use, right, these are relatively good. I showed them a few times already. They are gold plated, which is very important. But recently I noticed that they lost their, what do you call it, their properties, right? And the best way to see that is on the beeper. So here, as you can see, it no longer performs like it used to, right? It should be beeping every time I touch them, and it rarely does. It does when I put them together, but that's not the fault of the multimeter. Multimeter is very fast. It should register this, and as you can see, it no longer does. So one thing that was recommended to me some time ago was to put deoxit from time to time, put deoxit on the probes, right? And very important is to always keep them closed so they don't oxidize, they are not exposed to the environment. Now, this is the most important part, even if you don't use deoxit. Why did these probes suddenly stop working about a week ago? Because I left them like this for a couple weeks, right? I forgot to cover them, and I haven't been using the multimeter for a while because I've been mainly doing motherboards and stuff that I don't need the multimeter for, because this is mainly for diagnosing purposes, right? And that's what happened. Right? I did put some deoxit on it. I tried cleaning it, but nothing works. The surface oxidized too much, and these are done. So what I did, I went to AliExpress and I got myself 4 different probes. The ones we're gonna look at today is SS024B, SS024A. I think the difference is the ability to replace the tips. That is also very important, because if these were replaceable, I would just replace the tips alone. Now I have to replace the entire probe. LW315, and this one, which doesn't come with a nice model, but we have SKU. It's K09925-1VN. Now these actually look like the multimeter probes that came with my cheap multimeter. Oh no, actually, no, scratch that. So first thing that you will always notice on the probes is how flexible the cable is, right? You want it to be flexible, to have a silicone insulation, because that makes it nice and soft, nice and flexible. The ones with plastic insulation, they are very brittle, they are very hard to bend, and they will cause breaking of the cable inside. Now the breakage of the cable inside is very serious because it's a subtle issue and it can send you on the wild goose chase every time you measure. So let's start with the cheap ones. Well, they seem to be gold plated, or is it stainless steel? They seem to be gold plated. So what criteria are we going to use to test these? So let's consider what do we use multimeter for most commonly. Most common uses are voltage measurement, obviously, and resistance. The less common is measuring current, measuring capacitance, measuring frequency. For frequency measurements, these probes in general are not the best. For frequency measurement, you probably want a coaxial cable, so it doesn't interfere with the ether around it, because every wire is going to be an antenna as well. There's no way to tell the cable to just be cable and not be antenna, and tell antenna to just be antenna and not a cable. So these are basically interchangeable. So when you connect them to the multimeter and you try to measure frequency, you're going to pick up 50 or 60 hertz from the mains, depending on where you live. That is normal. That is something we have to live with, because the multimeter is not necessarily a good device for measuring frequency. But we are going to measure frequency as well. We're going to measure resistance, and we're going to measure the resistance of the probes themselves. Now, obviously, the best theoretical probe is the one that has no resistance. It's a perfect conductor. That is not necessarily possible. There are ways around it, using 2 cables per probe to eliminate the resistance of the loop, sure. But if we use just 2 cables, one for one terminal and the other for the other one, there's no way to bypass resistance of the probes. So our first measurement will be measuring the resistance of this tip alone from this point to this point, right? It's never going to be 0, but we want it as close to 0 as we can get it. Now if we touch the tip, it's 0.1, well, 1 milliohm, and even fluctuates between 0 and 1. So this is next to nothing, right? This is what we're measuring. And this is what we want to see. And for reference, if you think that's not a big deal and it will always show 0, this is stainless steel, rusty stainless steel. Yeah, it doesn't rust, but it accumulates all kinds of gunk on it. And that shows us 36 milliohms. That's huge for such a short distance. But it's mainly because of the oxidation on the surface of the metal. It's not the resistance of the metal itself. But that's how we measure, right? That's what we touch to the circuit to measure something. If you're measuring resistance, this cable would give you much higher resistance than you're actually measuring, than the real resistance, right? Now let's see if we can measure the entire cable. This might be tricky. Oh, maybe it'll work. To the very tip. And we have 88 milliohms. Not too bad. I would like to see it in the 50s, but 88, as long as it's below 100 milliohms, that's pretty good. Depending on what kind of measurements you do, but if you need to measure something that has 50 or 80 milliohms, you don't use the regular multimeter. Again, you need a probe that has 2 cables going to each terminal, to each lead. Okay, so now let's see. It's not the best. It is better. I think it is a little better, but that's not what I would expect. Let's see, let's continue with the, let's see the diode. Okay, on the diode, it's a lot faster. That is not bad. Not bad at all. So the diode is faster on this multimeter than the continuity. It's good to know. I didn't know that. Okay, now the resistance. We are on the 500 ohm range, and if we touch the tips, now as we can see, now it's showing 200. The accuracy of this multimeter is not that great. So one probe showed us 88, right? So the meter seems to think it's closer to 100, which is fine. It's off by 15, 18 milliohms. That's not bad. And obviously times 2 because we have 2 probes, right? So it's 200 milliohms when we touch tip to tip. Not bad. Not bad. Let me write it down. Now what we want is to check the frequency. We're going to use 1 megahertz because it's high frequency. As you can see, we're picking up 60 hertz, but that is normal. Okay, I think this multimeter doesn't go to 1 megahertz. So we're going to do 100 kilohertz. So 100 kilohertz is 14 hertz off, which is good. It's not bad. Okay, I say they are not bad. The cups are, the cover is made of rubber, not plastic, or at least very flexible plastic. If it is plastic, it could be, but it feels more like rubber. The cables are very nice and flexible. It doesn't feel cheap. It looks like those probes that you get with cheap multimeters, but it is not. In addition, you also have caps to cover this side of the leads, this side of the probes. So now we can hang it and it can stay. You can probably put a little bit of deoxide on it before closing it, like so. And this can sit for a while because it's nicely covered. Very important. Always keep your tips covered. Next one, SS024A. Super hard, super sharp. Okay, that is the measurement that we're not doing here. How much can the tip actually withstand? How hard is it? But in general, I believe that tips should not be used for anything other than actually measuring. However, in some cases, you take the probe and you need to just kind of make a puncture in whatever you're measuring to go through the oxidation layer or perhaps a conformal coating or something. So you need them to be sharp and you need them to go deep inside something to get more accurate measurement. That could even be solder. Solder typically doesn't oxidize, at least not as the copper would, but it will still have a little layer of something on it, and you will notice that if you just touch the soldering points, you don't get as well as accurate measurement as when you actually puncture and stick the probes inside the solder. You get much better measurement there. So that's why I like my probes to have very sharp tips. Okay, already I can tell you that these are crappy. So the insulation is more plasticky. So as you can see, it stays in the position that it was bent to, right? All those kinks and folds, they just stay, right? While these are perfectly straight, right? Here's the difference. So already I don't like these. Let's see what we can measure on them. The tips look pretty much the same. They're not replaceable, but I really don't like the cable. The cable is awful. That's why I got so many, because you can't really tell. They give you descriptions, sure, but until you actually get it, you don't know what you're getting. So let's check the black probe and see the resistance of it. It's actually better than I thought. It's 84. So slightly better than the previous one, which means tip to tip, they should give us a little better resistance, lower resistance, probably 180, 190 ohms, milliamps, of course, milliamps. If it was 180 ohms on the probes, they would be long in the trash by now. My dog Arlo is saying hi, I guess. Well, that's no good. Why is it more than 200? Well, but we can't argue with the measurements. It looks like going to 210 even. I think we're gonna average it as at around 205. What do you think? 204, 205, maybe 204. It goes down to 202, so let's go with 204. Let's see the resistance of the tip. The previous one was almost 0. Oh, much higher. 9. That's crazy. Yeah, the tip is not that great. 8, 9, that is crazy. It's crazy high resistance of the tip. So the tip is not good. Not good at all. It looks like it's dirty. Yeah, this is definitely... So 2 problems with this probe. First of all, the cable, and second, the resistance. Resistance way too high. I don't think there's even a point in measuring frequency, but let's do it just for the heck of it. It's a little closer by 1 hertz. Okay, so these go directly to the junk drawer. Not good. Not recommended. Mainly because of the cable. I just really don't like the cable. I can't work with the cable that is this rigid. I've seen worse. Actually, the probes that come with a fluke multimeter are even worse than this. So now let's try the B. Same thing, only instead of A we have B, and I think these are have replaceable tips. Oh yeah, check out how they come in packed. Yeah, I can tell the cable is really nice. Okay, is that a bug or a feature? I don't think it's a feature. Yeah, why do they not package them better? Because they all came in completely mangled. All of them. All the boxes. So, we have a damage. We have damage to the probes. Let's see. Okay. I straightened it a little bit. It looks better now. But perhaps it is damaged right inside, which kind of sucks, but what are you gonna do? That's China for you. We have replaceable tips, so we got 2 tips, our 2 sets of tips. So let's get 1 of each. This is the tip. It actually looks not too bad. So since we have the tip alone, let's see the resistance of the tip. Oh, that's not good. That is crazy not good. Like absolutely crazy not good. Really? The cheapest one with no even model marking is gonna be the best one? That's crazy. Let's grab it a little better. Oh, that's more like it. Maybe I wasn't, yeah, maybe I just didn't measure it correctly. But still, no, 7, you know, on this short route, 6 milliohms, that's crazy. That is absolutely crazy. Ridiculous high resistance. Well, let's try it. What are you gonna do? What do I need replaceable tips for if the tips themselves are crappy? Okay, they seem okay. All right, well, let's measure the black probe. See what it is. 37 milliohms, which is weird. So why are we getting this measurement? So looks like the cable is better than the tip. So just to compare, these are this probe, this whole probe from one side to another, right, has less than half of the resistance of all the previous ones, which I did not expect. Judging by the tip, I did not expect that. But looks like we can maybe clean the tips. Maybe that's the problem. The frequency the same, 0.13, but I didn't expect any different measurements on these. Let's see the whole resistance, tip to tip. Oh yeah, we got a winner. You know, the tip might be crappy, but the wire compensates. It is a lot. As you can see, the kinks don't stay on. Well, maybe a little bit, right? Not much, but a little bit. That means that the cable inside is a lot thicker compared to insulation. The insulation is rated for 200 degrees. This is 18 gauge wire. Okay, hard to place them on the scale. I mean, we do have a little damage, so we don't know if that affects anything. Doesn't seem to. It has higher resistance of the tip, but overall much lower resistance, like less than half of all the other ones, which is very important for the resistance measurements, especially when you measure low resistances. Let's measure a 4 ohm speaker. It should have roughly 3.7, 3.8 ohms. Yeah, 3.74, 3.73. It's not bad. These are actually not bad, but as I said, it's hard to rate them since they're kind of all over the place. I mean, I can tell that the cable is serious. This is serious cable. The probes themselves are very short, the handles, and very light. I'm used to them being this long, right? So they're massively shorter, which you might say is a feature, but I kind of got used to them being relatively long. I think that's easier. I don't know. Yeah, nice and short. They come with replaceable tips, which is an awesome feature. Those sleeves don't seem to want to stay on. I don't like that. Right, and you can see a little bit of gold. Right, it doesn't cover the entirety of the probe. Well, this part of the tip is not necessarily needed for anything. This is just so you can screw and unscrew it. But this, well, maybe it will not fall off by itself, but I don't like how it is not snugly. And the final ones, LW315. 20 amps, 1000 volts. That doesn't mean that you can push 20 amps at 1000 volts through them, right? These are separate measurements, okay? They can withstand 20 amps probably for a few seconds, probably at voltages around maybe 2 volts, maybe 5 volts, maybe even 10 volts. And the insulation on them is rated for 1000 volts. And we have replaceable needles. Okay, let's see if they are the same. As you can see, all the boxes are completely mangled. These packages went through hell. Okay, this is how it's packaged. It's the same size. It's a different probe. Oh, it feels very nice. This is silicone. This, right? This is cheap plastic, but this is very nice silicone. They actually feel very, very nice. The cable, I can already feel it's a silicone, and let's see, does it keep the kinks? Well, again, a little bit, not too much. It feels nice, springy. It's not bad. But there's no way to cover the tips. Oh no, there is some white cover on at the very tip of the tip. Okay, that's how it... Yeah, at least it fits snug. This is like some, I don't know, like insulation or something. Alright, let's see the resistance of the tip. So it looks like it's the same size. We'll see. Because if these tips are better, but these wires are not, then we can combine two crappy probes into one very good one. 10. So a little bit better, but again, it's absolutely crazy. It shouldn't be more than 2 milliohms, you know? Now let's see how it fits. Oh, it screws in a lot better. It's actually, yeah, it feels less cheap than the previous ones, or the previous one that has replaceable tips, or needles as they call it. There. Now let's see what it can do. Oh, this actually feels a lot better. Yeah, a lot less cheap. So let's see the resistance of the entire probe. I have a feeling it's gonna be not bad based on how the cable feels, but it's not gonna be easy. 35. Oh, we have a record. 34 even. Yeah, between 34 and 35. Okay, they definitely feel the best. Out of those 4, these feel the best. The cable, not bad. The tips, how they screw in, they feel very nice. How it plugs in to the multimeter feels a lot better. They don't offer as much resistance, they just slide in. The probes themselves, those handles, feel awesome. This feels like a professional multimeter. Now let's see resistance tip to tip. 120 was the lowest one, and 117 even, 119. It also kind of depends how you touch the probes, but I would average it to around 120, 121, maybe 122, because it goes to 117. So not too bad. Compared to the B, well, it had... Well, the B, it looks like the B has the best cables. The tips, pretty much awful on all of them except the first one, the cheapest one. And the cable feels a lot better on those cheapest ones, but the resistance of the wire, the tip to tip, is around 200 milliohms. While these are closer, these are 120 and these 104, so the lowest resistance. So looks like these, I probably will stay with these. The only problem I have with these is that they have very crappy those protective caps. It protects only the very tip of the tip, nothing more. And it looks like it's just mainly here so it doesn't puncture anything. So it doesn't protect the tip, it protects everything around it from the sharpness of the tip. And we have 2 more tips for replacement here. They do look the same as the other ones. So maybe I can just use the protective sleeve from the other ones. They definitely feel amazing. They're very light, which, you know, I'm used to my probes weighing a little more, so that's just a matter of getting used to, but I think it's better if the probes weigh less rather than more, especially if you use them all day. Let's see. They work the same way as all the other ones. Very quick. So not bad. Yeah, I think these are the winners. So the best probe so far, the LW315 replaceable tips. very nice cable, feel very nice, but don't come with a proper sleeve to protect the tip from oxidation and all that kind of stuff. This side of it is the best so far. It slides in with ease, but it's nice and firm. The second winner, or the second place, I have to give to these very cheap, but surprisingly very performant K09925-1. The cable is very nice. As you can see, it holds no kinks because it's not as thick inside the cable itself. Insulation is nice silicone. The resistance is 200 milliohms, which is high, relatively high, but the resistance of the tip is less than 1 milliohm. So very good tips, and the tips are nicely protected. They don't feel as great. The back doesn't slide in as nicely as these, but overall I'm very surprised that the cheap ones like this can perform this well. And the other two, no. The other two, well, one I already placed the box to go to the junk drawer, and these ones, despite having replaceable tips, not that great. They don't feel good. They feel cheap. They feel very cheap. It's a really nasty plastic on it. The cable holds a little bit of kinks here and there, but it is silicone. It's not bad. It's probably because the wire inside is much thicker, which typically is not bad. It's actually the opposite of bad. The other side, it slides in not as nicely as these. They're useful. They can be used, but they don't feel good. I don't like the tips, although the tips are not bad on these. No, was it these? No, these are awful tips. And the cable itself, not that great. The probe doesn't feel good. Probably junk drawer. Actually, let's place them where they belong. So out of these four, we have two candidates that we can actually use. And I think I'm gonna start by keeping these on my multimeter, mainly because they just feel really nice. It's pleasure holding them. My previous ones, although they performed well, they don't feel that great. They feel cheap. It's a rigid plastic, very brittle. The cables are really good though, and the tips are pretty good as well. But they are not replaceable, but the tips are very well protected in this. Now there's a lot more tests that we could do with those. Check how the insulation is melting, at what temperatures, what it smells like when it's melting. Check the plastic around it. Check the resistance to acids, and probably a few other things that I could think of to properly test them. But what we need is just probes that have the lowest possible resistance, the best possible conductivity, right? We could also test them at conducting current, right? Check on the 10, 20 amps at some low voltage. Then also check the maximum voltage that you can apply to the wire before we see the spark, right, on between the insulation, but that would probably be way more than 1000 volts. So there's plenty more tests that we could do to these, but again, we just want a regular probe for everyday use, and that's what these are, and these two work pretty well. The other two I don't recommend. Definitely if you get one of these two, I would probably go with these just because they feel a lot better. And the difference between those two is not massive. Kinda also depends on what you use them for. But if you need them for very precise measurements, then you probably don't buy your probes on AliExpress. You get them from reputable manufacturers. Alrighty, these are our probes. Hope you guys found this useful. If you have any questions, drop them in the comments. I can make some other measurements if we required them. Thank you very much for watching. I do appreciate you, and I shall see you in the next one.